In this video, we're going to be looking at the addition of ordinates. These are how you graph sum functions, so it's a method of how to graph them. So what do I mean by sum functions? Well, what I'm saying with sum functions is that you have like function fx is equal to gx plus hx. So it's when you have two functions, so you know how to graph gx, you know how to graph hx, but what about if you get a function like this? We have log x plus the square root of x. We don't know a general form for this, however we do know how to graph log x, we do know how to graph root x, so using addition of ordinates we can graph the result or the new function. So to begin with some simpler examples. So y is equal to x plus 2. So you should be able to graph this equation without using addition of ordinates, but I've decided to split it up. So I'm going to think about this equation as y is equal to fx plus gx, where fx is equal to x and gx is equal to 2. So fx is here, so y is equal to x, and then y is equal to 2 is there. So at each point, where the addition of ordinates is referring to each point, you have to add them two together. So we can start off by thinking about this point. Well, this point is at 2 here and is at 2. So effectively, what's 2 plus 2? Well, it's going to equal 4. So that means we can think about this point here is going to be at 2, 4, which if you sub that in, you can see is the correct answer. Then what about this point? Well, it's 0 here, and then it's 2 up here. So then here, it's just going to go through here, which is 0, 2. Because anything plus 0 is just going to be that same number. And you can go along and see that it's just going to be the exact same line, however you've added 2 at all the different points. So rather you're now going to get a line that looks something like that. However, it's going to be straight. And you can see, and then that you should also label that point, which will be negative 2, 0. And obviously you could have graphed that straight away, but I'm just showing how the addition of ordinates works. You find the 2 points at a particular x value for both the graphs, you add them together and you find the result. You can just go like that and that. This does point out an important point that when one is 0, the line goes through the other one. And that's because anything plus 0, as I mentioned before, is just that value. However, it's important when looking at being able to see the shape, and also a good starting point when there's more complicated graphs is to look when they intercept at the x-axis and seeing what happens to the other graph at that point. So now another example. Y is equal to x minus x. Now this seems like a bit of a stupid function because x minus x is just equal to 0. So y is equal to 0. And we can know that because any value minus that exact value will just equal 0. But now using addition of ordinates, does that hold true? So at this point here, we have y is equal to x is equal to 0 and y is equal to negative x is equal to 0. So that point there is just 0, 0. Then if we go along any other point, we can say that, let's say this point here. Then this point, let's say that is 2. This point here is negative 2. So 2 minus 2 will just give us 0. Then this point here, let's say it's negative 5. Then the corresponding value up here will be 5. And 5 minus 5 is 0. So the whole point of additional ordinates is that you find the different points. Obviously you don't have to go at every point, as you can start to see what the function will do. So you can see that as this is going up at the same gradient as this one is going down, then the result will just be always 0. And you can get the equation y is equal to 0. So now what about if we have two different equations? So firstly, y is equal to x squared and y is equal to 1 on x. So firstly, y is equal to x squared. We know that this graph looks like this, and it intercepts at 0, 0, y is equal to x squared. And then y is equal to 1 over x looks like that. So we know there's two different equations. So now that we know those two shapes, we can therefore work out what this function plus this function looks like. So if we want to graph y is equal to x squared plus 1 on x. So the first step is we have to draw in both of the original graphs. So y is equal to x squared, and then y is equal to 1 on x. So using addition of ordinates, we can think, oh, well, this point is going to be at 1, x is equal to 1, because when x is equal to 1 for both equations, y is equal to 1, so that's point 1, 1. So the corresponding point up here is going to be 2, 1. And so we got this point 2, 1. So let's look at the right of this 2, 1 point. So what is happening? Well, we're getting two positive numbers. So they're both going to, two positive numbers added together will always give you a positive number. Now, it's exponentially increasing, so it's going to have a similar similar shape, but then green is going towards 0. You can see here the green is getting smaller and smaller and smaller. So what you have is you have sort of like y is equal to x squared, so whatever these numbers are, plus another number. This number is getting smaller and smaller and smaller. So purple is going to look more and more like y equals x squared. So it's going to look like this. And the reason it's going to have the similar shape, but it's going to be on this side and get closer and closer but never touch, is because the difference between here and here is equal to the distance of green. Obviously this isn't to scale. However, if you think about it like this, where you have purple, we'll pick another point, so let's say there, then it's green plus yellow. So you can, this is like the y value of green, and then this yellow distance here, this y value, will be equal and equivalent to this value here. If that's confusing you, don't worry too much. Just think about it like you're adding two different points. If one's getting smaller, then it's not going to have as much of an impact. So the combined, the total, is going to approach the other one. So y is x squared. Then if we look at the left of this point, we can see that green is increasing and y is approaching 0. So it's going to be a similar thing now, but instead we now approaching the green value here. And that's it's going to increase higher than green because yellow is still positive. So because both are positive, it's still going to be greater at any x value than y is x squared or y is equal to 1 on x, but it will get closer because they're going towards 0. So does this function exist at x is equal to 0? Well, no, it doesn't, because 1 on 0 is undefined. Even though y is equal to x squared is defined at x is equal to 0, the 1 on x isn't. So for some functions, you have to look at both to see where it is defined. So it's defined only when both the functions are defined. Yeah, so we know that x does not equal 0 for this one. So looking at this point, one is now positive and one is negative. There will be a point here where the graph intercepts at x equals 0. And that's because if one's positive, one's negative, you can see that eventually the negative value and the positive value in magnitude will be the same, and you'll get something like 5 minus 5 is equal to 0, or whatever the value is. So we know that there is an intercept there. What is going to happen on either side? Well, if we look at this side first, to the left, then we know that green is still negative, but it's getting closer and closer to 0. And then y is equal to x squared is increasing. So this function here is going to be positive, and it's going to increase and increase. But it's going to increase less than y is equal to x squared because of the negative green. But eventually the negative green is going to approach 0 and get very, very small, so it's going to get closer and closer to this y equals x squared. Looking to the right of this point, we can see that y is getting closer to 0, but green is getting much larger, negative. So the function is going to be negative, and it's going to go down here, and it won't be as negative as green, but it'll get closer and closer as y approaches 0. So when you do the sum addition of ordinates, it's typically good to do two graphs. So do one sketch, one like this, where it's a bit rough and you're just trying to work it out, and then you draw like the good copy on a different set of axes. So we do have to work out what this point is, as normally you have to find out the x and y intercepts of a graph. So this is just letting y equal to 0. So 0 is equal to x squared plus 1 on x. So x squared is equal to 1 on x. Therefore x is equal to, x squared is equal to negative 1 on x. So x is equal to negative 1. So that point here is negative 1, 0. So drawing this graph neatly, we see that it looks like this, where that's the point where it intercepted, and negative 1, 0. Then you have a point where it turns and it approaches both of these here, and it starts to approach to infinity. Now, with this good copy, I still left in this green graph, y is equal to x squared and x is equal to 0. And the reason for this is these are both asymptotes. So if you thought that asymptotes could only be a straight line, that is actually incorrect, because asymptotes can also be have different shapes, such as y is equal to x squared. So these are both asymptotes. And the reason for this is that, if you remember before, when we had the equation y is x squared plus 1 on x. When x goes to infinity, 1 on x goes to 0, because 1 on a very, very large number approaches 0. So as this approaches 0, y will start to approach x squared, and we can see that here. And as y approaches this line, it acts as an asymptote. What happens when x approaches 0? Well, 1 on x approaches infinity. As 1 on x approaches infinity, then y approaches infinity. So you can see that this graph here is going to approach infinity, so x is equal to 0 is going to be an asymptote. Then on the other side, it also acts as an asymptote, because when you have x going to negative infinity, then 1 on x approaches 0 once again, but from the negative side, so then y will also approach x squared. As you can see, that's there. However, it's going to occur from the other side, as it's approaching 0 from the negative rather than 0 from the positive. When x approaches 0 once again from the negative side, then y will approach negative infinity, as 1 on x will approach negative infinity, as you can see going down there. So you have to be careful with the addition of ordinates that you do label y is equal to x squared as an asymptote, and I probably would write, especially if you only do one axis, definitely write y is equal to x squared and then specifically say it is an asymptote. Otherwise, you can draw it in a new graph, you can do a dotted line, and then it will be pretty obvious. But with the addition of ordinates, make sure you look at where it will intercept for the x-axis, where the graphs do intercept, because you'll be able to find those points, and then you should be able to look at the different parts of the graphs like I did before. I looked at the right, then the left, the right, then the left, and you can see the general shape of the function.